First up today is Vinay Kumar. Vinay serves as the database manager for SABR. He's new in that role. We're excited to have him. And today he'll be providing us with an introduction to baseball databases, specifically working with the Layman baseball database, which is housed at sabr.org. Vinay, we'll get you up and running here, and you can take it away.
All right. Good morning. Thanks, Scott. Welcome, everybody. I'm really excited to be here in the leadoff slot at the SABR Analytics Conference. It's the fourth time, I believe, I'm attending the conference and my first time presenting. So I'm pretty excited to be presenting here, to be a part of the conference, not just a fly on the wall. And let's get started. So a little bit about me. My name is Vinay Kumar. I've been a baseball fan for as long as I can remember. I'm also a self-confessed stat nerd and have been for my life. I was very fortunate as a little kid that the public library local to my home had books by SABR legends like Pete Palmer and Bill James, and I devoured everything I could get my hands on as a kid, including some of these really stat-heavy books. And I've been into statistics and numbers my whole life, especially via baseball. And so when SABR asked me earlier this offseason to come and take over some of the database projects, and specifically the Layman database, I jumped at it. I was excited. My passion the last couple of years has actually been making baseball data more accessible to the broader research community. So something like this, where I'm sharing what's available and how to get started with a community of people who are very interested and many new to the industry here, it's very exciting to me. It's really what I want to do for the industry. So this is really exciting, and I'm glad that there's so many people here. Like I said, I've got the coveted leadoff spot for the analytics convention. So hopefully I'll get on base and keep the rally going for everybody. So there's basically, as Scott mentioned, a couple of things we're going to go through here. The first is I want to walk through what's the current baseball data landscape. And we can't cover everything, but we're going to walk through what are the major baseball data providers, how do they work, what kind of data can we get from which places. Then we're going to do a deep dive on the Layman database. And if you don't know what the Layman database is yet, don't worry, I'm going to get into it in detail and really describe it. And the part that I'm really excited about, this isn't just a slideshow. We're going to do some live querying and examples. I've got a database tool ready to go. We're going to do some live querying. Hopefully I don't screw it up. I did a little bit of practicing, so I should be able to do it well. But the goal of this presentation is for everybody to get their hands a little dirty, and understand the landscape a little bit, and really to pique your curiosity. So I know we've got a wide, the audience here. Some of you are really into baseball. Some of you are more into programming and data science and less into baseball. Some of you have been playing with baseball data for months or years. Some are brand new. So really, it's to show what's out there, get people excited and curious, and give you just enough information to really sate your curiosity, to go and find databases and data sources you can play with, know some tools that you can use on them, have enough information about how they work together that you can really go out there and start to do some real research almost immediately. So, that's a very ambitious goal. Nobody's going to be an expert after 45 minutes here, but like I said, hopefully it's enough to get you curious and looking to dive in and learn more on your own. So let's start with the state of baseball data. And whenever I talk about this, I always preference it with the phrase, we baseball nerds are very lucky because we have so much data available to us. It's almost all free. The community is super helpful. You can find examples of how to do anything online. People are, you can talk to anybody, ask questions, and people will help. And I've dabbled in other sports, and that doesn't exist in any other sport. So let's just acknowledge that we're super fortunate that in baseball we have a lot of access to data. And so I'm going to present, at a very high level, a handful of data sources, kind of going from most accessible to least accessible, but it's not strictly in that order. And for each one, I'm going to cover what's the resource, what kind of data is available, and how do you get access to it? What kind of skills do you need to work with that data, skills and tools? So at the highest level, we have many great websites for baseball data. The two most well-known and comprehensive are Fangraphs and Baseball Reference, and I just realized I misspelled Fangraphs, and I apologize. But these websites both have an absolute trove of data, historical data, analytics data, play-by-play, splits, everything you can imagine. And they make it relatively easy to take that data and work with it. So you can copy and paste a table out of either of those websites into Excel. You can download a CSV file to open it up with another programming language or with another tool. It's
Hey,
all,
Vinay, sorry to interrupt. If you're
yeah.
supposed to be sharing slides, I don't see them yet. So you want
Uh-oh.
to?
Thank you for.
Yeah, no problem.
Okay.
Bingo.
Here we go. Okay. Thank you for catching me. Well, you guys didn't miss much. I just basically, we're on the first row of this table. So you wouldn't have even seen the typo if I hadn't mentioned it. Anyway, so these sites are fantastic. They're great for a user just browsing, but also you can copy the data from these sites and work in whatever tools feel handy. It can be kind of manual. They're not meant to be programming interfaces. You have to either as a user copy and paste data, or you have to you have to have some knowledge about web scraping to get the data from these sites. But there's a ton there. It's really awesome. And a lot of people, actually a lot of great research has been done just using these websites and not using any more advanced databases or anything else, because there's so much available there. The next set of data is what's known as the Lehman database. And we'll get into some more detail in a minute about where it comes from, but this has been primarily a volunteer-driven effort by Sean Lehman and others. It's historical year-by-year player and team stats. So the scope there is really important, year-by-year player and team stats. So it's not going to have splits. It's not going to have things like WAR. It's really about the data, and specifically the historical data. And year-by-year player and team stats for every year. And what's really cool, it's a downloadable database. And we'll get into a little bit more into why that's really cool. But the idea is you can download it. You have all the data available locally on your computer. You can manipulate it. You can open it in various applications. So that's really powerful. Oops. The next one is a stat head play index, which is part of Baseball Reference. It's a really powerful tool. It's very powerful. It gives you the ability to essentially treat the Baseball Reference as a database that you can query. And it has all sorts of ways to query it by player, by team, looking at splits, combining multiple seasons into careers. So it gives you all that power of a database without having to install anything, without having to really know how to do that personally. It's a form-based user interface. So it's really great for a person who wants to access that data, but it's very manual. You have to sit there and interact with the form. You can't really automate it. It is a paid tool, but you get the power of a database, with all of the access to the data that is behind Baseball Reference, all from one GUI. It's very powerful and it's really cool. The next set of data is from RetroSheet. So RetroSheet is another nonprofit, and their focus has been to essentially digitize the historical play-by-play of all of baseball. So they've been working backwards. They started in the 80s and 90s and then went back through the 70s and have gone back decade by decade, getting baseball data from newspapers and other historical sources and digitizing the play-by-play data, and then making that play-by-play data available for free for people to reuse as they like. And so it's really cool. A lot of the research that we've seen, a lot of the splits, a lot of things that we've learned about things like the third time through the order or platoon splits, it's made possible by RetroSheet data. When you have play-by-play data, you can slice and dice it into various ways, and it enables you to really do some of that more in-depth research. Again, it's all volunteer-led. All of the data is available to download. There's a bit of a learning curve. If I had another hour today, I would love to spend an hour going on how to learn how to use RetroSheet data, but we don't have another hour. So I really encourage everybody to play with RetroSheet data at some point. But I do, there is a bit of learning curve. It is, it's not the first thing to grab onto from this list. The next kind of, as we move up in complexity and power, is the MLB Stats API. So this is provided by MLB. The way I kind of describe it, this was initially created to support MLB's own websites and mobile apps. And so everything you can see in the mobile app is available via the MLB Stats API. So that includes real-time play-by-play data, things like attendance, lineups, some biographical data about the players. MLB makes it all available. Like I said, they made it available initially for their own apps. They found that it's really powerful to make it available to the public. It's available via a web API, an HTTP JSON API, if you know that technology, which means it's actually less useful as a human being. It's really made for computer programs. You can write code that will query this API. You can call it repeatedly in real time and get real-time updates. So again, it's very powerful data, real time, but it really helps to be a programmer to get access to it. It's not easy just as a person playing with their browser. And then possibly the most advanced data is Baseball Savant, which includes the StatCast data. So all of the new data we've seen over the last 5-10 years that MLB is tracking in real time on the field, things that we see like exit velocities, launch angles, spin rates, precise pitch movements, fielders movements, all that stuff is available at Baseball Savant. There's a web interface to allow you to query the data, so you can download tables of it at a time. It's really powerful. A lot of the research that we see on sites like Baseball Prospectus and Fangraphs, which is really cutting edge, and on Twitter and on various blogs, people are using StatCast data and they're getting it from Baseball Savant. Again, this is mostly a web scraping API. You go to the website, you can interact with the forms there, figure out what you want. You can potentially write some code to get that data directly. So it's a combination of humans sitting at a web browser. It can be accessible, or from within a program, download the data, open it up with whatever database tools or spreadsheets. So I think what this shows is that there's a lot of different sources. It can be kind of overwhelming as to where to begin. You might read an article and somebody might reference where they got their data from, and that's helpful. But I think the key is, depending on what you're trying to do and what skills you have, there are different starting points that make sense for different people. So really think about the scope, what data is available from what data source, what kind of skills you have, what kind of tools you have, and that might lead you into where to start first. And then as you think, oh, I really want to get into the play-by-play data, I really want to learn retro sheet. Okay, at some point, maybe you then tackle that learning curve. But different people will choose different starting points. I think the sweet spot for most of the people in this audience, and again, acknowledging that I know we have a wide variety of skill sets and experience levels here, is the layman database. And the reason for that, it's very accessible. You can download it directly from SABR. It has quite a lot of data that's really powerful without becoming too overwhelming. And frankly, it is now, it's part of SABR, and SABR is distributing it. So we really want to share the power of this database and want people to use it. So the first question, the starting point, what is the layman database? I expect that there are some people who are familiar with it. Maybe some of you have downloaded it and used it, but a lot of you might not have heard of it, and that's okay. So the key there is the scope. For the most part, it's season by season stats totals for all of AL and NL history. So, and there are other leagues too. There's a lot of 19th century leagues. We don't have the Negro League stats yet. So it wouldn't be fair to say all of MLB history. The Negro Leagues are major leagues, but the statistics are very spotty. But for AL, NL history, we have full season by season stats for all players and teams. Oops. I clicked on the link accidentally. It includes other tables as well. Biographical data, managers, awards, Hall of Fame voting, etc. It was created by Sean Lehman in 1995, and what was really key, this was volunteer work that he did, but he made it available for free as a download for everybody. And this launched a new generation of baseball research. It might not seem like that big a deal, but I think there are a few landmark innovations in baseball history that enabled generations of research. One was the Big Mac Encyclopedia in the 1960s, where there was a book that you could get all of the statistical data. And there are a few more, and I won't go into all of them, but one was this layman database, a database that was available for everybody with all of this data and the types of things that, projection systems, aging curves, things that we take for granted in baseball research now didn't really exist until the mid-90s because the data was so hard to come by. And suddenly, when you could have 100 years of baseball data at your fingertips, then you could do things like look at, well, how does a player's walk rate change over time as he ages? Before that, I mean, I remember this. You literally have to sit there with a magazine or a book and type that data into Excel. And you could spend all off season and have 1 year of data. And suddenly you had the whole history of baseball data. And so many baseball researchers owe a lot of their work either directly or indirectly to the layman database. Directly in that they downloaded it and used it directly. Indirectly, they used other sources like Baseball Reference that have been built on top of the layman database over the years. As has been mentioned, Sean stepped aside and kindly donated this database to SABR in 2024. And when SABR asked me to come and maintain it moving forward, I was very excited because I've been using this database for nearly 30 years. So it's an opportunity to pay it back and pay it forward at the same time. And so we're working on that transition now, and we'll hopefully have the new annual update out soon. But as Scott mentioned, it's housed on SABR. That's the link to go get it from sabr.org. If you Google layman database, you will also find that SABR link as well as Sean Layman's website, where he has some more information on it. One of the things that I love about the layman database, it's actually available in two formats. And one is comma-separated files. And most people, I think, are familiar with comma-separated values, CSV files. It's arguably the most portable format. Practically any spreadsheet program, any data visualization program, almost any programming language has support for opening comma-separated values and parsing them into usable data. So if you don't know what to use, comma-separated values are very accessible to almost everybody. Additionally, Sean has published in the past Microsoft database formats. This data includes even more structure about the meaning of the data and how it's all related, and we'll get into that in a minute. It requires Microsoft-specific database tools, and many people have access to these tools, no pun intended. Microsoft Access is a part of Microsoft Office. So between academia and the corporate world, a lot of people have access to Microsoft tools. So if you have Microsoft tools, you're familiar with them, feel free to download a Microsoft format, use the Microsoft tools. If you don't know what any of that is, if you don't know if you have it, if you don't know if you can get it, don't worry about it. Just download the comma-separated formats. You can open it in almost any tool. You can open it in a spreadsheet, which is, I think, what most people are probably familiar with. Excuse me. And that's what we're going to do first. I'm going to open this database up in a spreadsheet, one of the tables from the spreadsheet from the database, and we're going to play with it in a spreadsheet for a little bit. So let's hopefully work that the screen share works, as I'm going to stop sharing my slides and then start sharing my spreadsheet. Okay, so this spreadsheet app is the Numbers app. It's the built-in spreadsheet app. It comes with Mac OS. So one of the great things about spreadsheets is practically everybody has access to spreadsheet software. Microsoft Excel is pretty ubiquitous. Google Sheets is pretty ubiquitous. Everybody has access to the software practically. People have used it for various things. So the learning curve is a little easier to navigate. And what we're looking at right now is the batting table. So there are a number of tables in the layman database, and we're going to browse through them. But this is, I think, kind of the one that I spend the most time with, and a lot of people do. I mentioned the meat of the database is year-by-year statistical totals. And so if you look, this is a year-by-year for each player, their batting totals. It's sorted alphabetically. Here's David Aardsma, who is the first player alphabetically in all of MLB. Then Hank Aaron is next. And we can see for each season, there's a row. And we have their team ID, the league ID, the number of games, at-bats, runs, hits, etc. And this is in a spreadsheet. We can do a lot of things with it already out of the box. So what if we're curious about who's hit the most home runs in a single season? Well, that's easy enough. We can just sort this column. And it's taking a second. It's a lot of data. It tells us right here, numbers, it summarizes some of the data. They're saying there's 113 rows in this database. So that's why it's a little slow. It's every player season in the history of MLB. And you can see, okay, this is just what we'd expect. Barry Bonds, Sammy Sosa, Aaron Judge, Roger Maris, Babe Ruth. It's missing Mark McGwire. That's really odd. I was expecting it to miss one Mark McGwire season, but it's missing a couple of Mark McGwire seasons. I think I might have been playing with it before the session and actually screwed something up. But the idea being that you've got all of the players, you can sort it. And so we can sort it on any field. It's a little bit slow. Okay, cool. There's a lot of power in spreadsheets. So what if we wanted to look at career home runs rather than single season home runs? Well, what we want to do is sum across all players. So we can create a pivot table, which is a spreadsheet tool for aggregating and slicing and dicing data. And so we can say we want all the players on one side, and you can see it's a little slow because it's a lot of data to be working in a spreadsheet app with. And we want the home runs here, and it gives us, by default, the sum of the home runs. And there we see Henry Aaron is at 755 home runs. We can sort this value descending. And you'll notice each time, it might be left apparent over Zoom, but I feel it on my computer that it's a little laggy. It's a little slow to respond. This is a lot of data. But the idea is all of the data that's in the layman database, you can open up CSV files. You can access it in Excel. You don't need programming tools. You don't need any specialized skills. One thing you'll notice is that it's not showing the players' names. These are IDs. So some of these names are very familiar. We can figure out that's Barry Bonds, that's Hank Aaron, that's Babe Ruth, but the actual player names are in another table. And in Excel, in numbers, we can get those names using lookups, and there are other ways to link tables together. It can all be done in spreadsheets, but some of it is a lot of work. So that's kind of the overview of how to get started with it with spreadsheets. There's a lot at your fingertips, but it does start to kind of push the limits of what spreadsheets can do. Like I said, it's a lot of data, it's slow. The simple things we did just now are simple, but things like looking up the names and inserting them can be a little bit more work. And as we want to link multiple tables together, it's all doable in a spreadsheet, but the more tables you're playing with, the more links you have between them, it becomes more complex. So we're going to go back to the slides for just a moment. And so let's look at some of the key takeaways from using a spreadsheet. So the pros, like I mentioned, the tools and skills are very accessible. Everybody's got access to these tools, not quite everybody, but most people. There are tutorials everywhere. There's a lot of resources online. If you get really good at Excel, that skill will be valuable for you in almost anything you do anywhere in school or your career, and vice versa. If you learn Excel elsewhere, you can apply it to baseball. So the tools and skills are really accessible and transferable. It's easy to sort and filter data. Like we saw, you just can right click on a column and sort. You can create filters very easily. So it's pretty easy to get started and just jump in and explore data. It's easy to add columns with formulas. I didn't show that. I'm trying to move a little more quickly, but it's very easy to add a column, put in the formula for batting average, and boom, you've got more data that you can play with. And we can link sheets using lookups and so on. And that takes, some people might consider that a little bit more advanced spreadsheeting, or it's a matter of learning how to do it, but it can all be done using lookups. But like I mentioned, there's some cons, and they all have to do with scaling. So we see limitations on table sizes. This is a lot of data, and that's just the batting table out of the box. Once you start to combine tables, they can become very big. You can, if you're starting to, if you're looking for something like comparable players, you want to say who's the player who looked the most comparable to Rickey Henderson in 1984. Well, you suddenly have to, you're combining tables with themselves. You have n squared problems. It becomes really hard to do with a spreadsheet. But that's exactly what database systems are really good at. It's hard to link more than a few sheets together. A lot of the formulas are very manual. You can do things with more than a few spreadsheets, but I think anybody who's worked with spreadsheets that have more than a few tabs, even when you have more than a few tabs, you tend to have relationships only between one or two of them at a time. It's really unwieldy to have more complex queries and complex relationships between the data. And actually working in the database, it can be easy to get started. You just start clicking on buttons, right-clicking on data, but a lot of the work is manual. And so if you want to, if you have multiple tables and you want to add the same formula to them, you have to do a lot of the same work repeatedly. And that can be error prone. It requires manual steps. If you want to go back and change something you did in the spreadsheet, it can be hard to retrace your steps. So really great at getting started, but not necessarily the best at scaling. So what is good at scaling? Relational databases, also known as SQL databases. And really the idea behind a relational database is that the data is very structured, and so we can build more complex systems that are more scalable. So the idea is that the data is organized into tables, and we have clearly defined relationships between them. And you can think of as a table as something like a tab in Excel or Google Sheets. So we have many tables, but one thing with relational databases is we clearly define the relationships between them, which makes it much easier than to work with multiple tables at a time. And we'll get into that with an example in just a minute. And we use unique IDs to unambiguously refer to entities. There's, that's a sentence that's a little hard to get through, but we just saw this in the example, even in the spreadsheet, this idea where it was using player IDs. So rather than, I was looking at a player named Bill Swift a few days ago. I remember him as a pitcher from the 90s. I didn't realize there was also a pitcher from the 40s named Bill Swift. And if the database rows just mentioned Bill Swift, we would have to disambiguate which Bill Swift is it. By using player IDs, we saw the IDs before, the Bonds BA01. Those are unambiguous. So Bill Swift of the 90s has a different ID from Bill Swift of the 40s, which makes it relatively straightforward to write queries. And then we have standardized querying via what's known as the structured query language, SQL. And so that gives us a standard way. Once you learn SQL, and we're going to do a very basic intro on it in just a minute, you can query all sorts of data sets. There are all sorts of tools that help you build SQL. So even if you don't know how to write SQL, there are visual tools, and that's what we're going to use in a minute to write our first query, that will write your queries for you. And even if you don't use SQL itself, the concepts of structured querying are actually implemented in a lot of different programming languages. So if you use Python or R, which are two programming languages which are very popular for analytics, the same context, the same concepts apply. If your data is structured, you can really do very powerful things with it in terms of querying across multiple tables, grouping, etc. And all queries and operations are represented as code. So this is really powerful because you can take a query, you can save it to a file. You can easily send it to somebody. You can make a slight modification and have 2 copies of it. This is as opposed to when we were working in a spreadsheet and everything is done through a GUI. And GUIs are really powerful, but it's really hard to go back and understand what you did, to share your steps, to repeatedly apply those steps consistently. Whereas when something is represented as code, you can essentially run the same code twice. You can make a small modification and run the modified code. You can go back and save your code in source control. So there are a lot of advantages there. And like I mentioned, there are many tools available. I'm going to mention a couple here, but the key is really that there are so many tools. This is one of the benefits of standardizing on SQL. So Microsoft Access, like I mentioned, is widely available. Many of you might have it on your laptops already. And it includes a lot of visualization features. So you can learn SQL without really having to know how to write code in SQL. And then there's another tool I like called dbeaver, which is a cross-platform tool available on the Mac. It's a free download to get started. There's a license to continue using it. And it has some of the same features, including visualization, so a visual query builder, which is what I'm going to use dbeaver for. So I'm not necessarily recommending it, but it works for me. And the key, there are many tools available. If there's anything you've used, somebody you know recommends one, go for it. They can, that's one of the powers of using a SQL database, is that there are lots of tools available at different prices and levels of features, depending on what you want to do. So let's jump into the database now for a minute. And I'm actually going to share my dbeaver window. There's a lot going on the screen. Don't try to understand all of it. I'm going to walk through the parts that are important. Initially, it's this data table. This is the same batting table that we saw before in the spreadsheet. Same batting, it's all the same fields, games, at-bats, runs, hits, doubles, the same idea of one row per player season. We can even do some of the same things. This view acts like a spreadsheet in some ways. So we can say order by home runs descending, and we see the same list: Barry Bonds, Mark McGwire, Sammy Sosa, Mark McGwire, Sammy Sosa, Aaron Judge. And so there's a couple Mark McGwire seasons on here, but we're missing a season. He had another season where he hit 57 home runs, which is not here. And I'm going to skip ahead, and I know why that's happening. And that's because Mark McGwire had a season where he was traded, and that shows up as 2 rows here. So if we can filter this by the name Mark McGwire. Oops. Okay, didn't like that filter. So what we actually need to do to look at who has hit the most home runs in a season, we need to look at partial seasons together now. So this is our first SQL query that we're going to do. So we say, let's start a new SQL script and use a visual query builder. So again, there's a lot going on the screen, but the idea with a visual query builder is we can actually use drag and drop and visual tools. So we say we want to look at the batting table. We want to aggregate by player ID, year ID. I'm going a little fast now. I'll explain this in a minute in just a second. Actually, I'm going to actually do things in a different order than I had initially said. I'm going to go back to the slides for a second and walk through what a query can look like. So let's do a little introduction on what a SQL query looks like. And one of the things I like about SQL is it's intended to be kind of like natural language. Like you can walk through it and understand what's happening. So the idea you start with, and this is sort of my mental model of a SQL query. You start with from. Which tables do you want to query? There's a lot of tables in the layman database. Sometimes you're only looking at one. Sometimes you want to look at a few of them. So you identify which tables do we want to look at to gather data from. The next step is to join tables. If we have multiple tables, how do we combine them? And if we only have one table, we can skip that step. So for a simple query, you can kind of skip over that for now. The next step is where. You can apply conditions. We can apply filters. If we only want some data, if we only want to look at data since the year 2000, you can use a where clause to filter your data to the year 2000. We can group by data. We can aggregate data. So for example, if we want to look for players' career home runs, we can aggregate based on the player ID and then sum, and that way we can get player career stats. And we'll come back to that in a second. We can order by, so we can choose which fields we want to sort on. And what I think of last is select, which is when we define which fields we want to show from these queries. I I think people who are familiar with SQL are immediately objecting because the way that SQL actually works, your select has to go on top. So this is the same list of query parameters, but I've moved the select to the top. But the way I tend to read and write SQL, I start with the from and I go sort of outwards from there. Select is actually the last thing I do. So as we go back to the query editor, I think that'll help as I walk through how to do queries. So let's jump in with one hands-on example. I have two here that I had teed up. I think we really only have time to get through one, which is this first one. Who hit the most home runs for any one franchise? So we already know that Barry Bonds hit the most home runs in Major League history. Hank Aaron hit the most before Bonds, Babe Ruth before that. They all played for more than one team. And so the question is, who hit the most for any one franchise? And so to answer this, let's go back to our database editor, back to DBer. All right. And first, I'm going to walk through the tables here. And I mentioned there's a bunch of tables in the database. The most interesting ones, or probably the most commonly used ones, I should say, batting, pitching, that's year-by-year batting, year-by-year pitching. People is biographical data of people. So we can click on any of these and look at them and see what fields are in a table. So for a player, we have a player ID, their birth date, death date, name, biographical data like weight, height, throws, and so on. We have teams. So that's year-by-year data for teams throughout baseball history, including wins, losses, their statistical batting and pitching data. We have parks, salaries. So there's a lot of data, awards, award shares. So that's like for every award vote, which player got how much of the voting did each player get? So there's a ton of data here. No way we can cover it all now. I encourage people to dive in, start exploring, but it's really powerful, the things you can do, especially when you have multiple tables and you put them together. So let's go back to the query that we talked about. So start a new SQL script with a visual query builder. And what this is going to do, we can build a query. We're looking again, remember, for the players who hit the most home runs for a single franchise. So we start with the batting table because that has players and their batting stats. And you can see it started to build some SQL here from batting B. And what this is saying, use the batting table, and we're going to call it B for short in the rest of this query. We don't really have any conditions that we're applying here. For now, we're only working with one table. What we do want to do, though, is group by. So we say we want to group by a player. So how many home runs? So think about Barry Bonds for a second. We want to total up how many home runs did Barry Bonds hit for the Giants. So we were interested in the player ID and the team ID. And this lets us define, do we want to group these? And we want to group on both of these. And you can see it's modified our SQL here. It's added both of those to the select that we want to see the player ID and the team ID. And then we're going to group by the player ID and the team ID. Well, once we group all of these rows by player ID and team ID, what do we want to do? We want to see the sum of the home runs. So we'll check on home runs, means we're interested in home runs. And when you group by something, you have to aggregate the other fields. So if we're grouping things by player ID and team ID, we have to tell this query, how do we combine the home run numbers? And we want to sum. So here's a query, it's built for us. So it's saying that it's going to sum the home runs from batting B and grouping by the player ID and the team ID. So let's run this query. And we didn't tell it how to sort, so it's actually still showing David Aardsma, and he played for a bunch of teams and hit 0 home runs for every single one of them. And we can sort here Oops, I did it by player ID. Actually, let's do this. Let's do this in the query. We can tell it how to sort here. So we want to sort, and this is a little tricky. We have to tell it what we want to sort on is the sum of the home runs. So we tell it that's the column that we're going to sort on, and we're going to sort on descending. We want the highest values first. So let's run this query. It should be the same data, but now sorted. And we see Babe Ruth has 659 home runs for the Yankees. Barry Bonds, 586 for the Giants. Mike Schmidt, 548 for the Phillies. So we're seeing some of the highest totals. We're seeing who we expected to see. Except there's one player who's missing. There's Henry Aaron. And why isn't Henry Aaron on here? He played most of his career for the Braves. I'm pretty sure he hit at least 600 home runs for the Braves. So if we go back to this batting table and we sort it by player ID again, why isn't this going? If you look at Hank Aaron, it actually shows two different teams. He played on ML1 Montreal for a number of years, and then he played on ATL Atlanta. Well, both of those were the Braves. And do we really want to separate the Milwaukee years from the Atlanta years when talking about Henry Aaron's career with the Braves? My intention was not to separate them. I thought the Braves are the Braves. But the problem is that this table has a team ID, and the team ID can change for a franchise. But we really care about our franchises, not teams. Now, how do we sum by franchise? Well, the franchise information isn't in this table, so we need to use a different table. And if we go back to our query here, I already know the table that we need is the teams table. If you weren't familiar, you could poke around and look at the different tables. But in the teams table, you'll see there's a franchise ID here. And so the aha is that we need to connect the batting table to the teams table and group on the franchise ID, not the team ID. So we go back to our query, and now we have, you can see we've got two tables here, the batting table and the teams table. But we have to tell the database how these columns, which columns are related in these tables. So the key is that we have a team ID and a year ID here, and they match up to the team ID and a year ID in the teams table. So we can just drag from the year ID here to the year ID here, and the team ID here to the team ID here. And it has created this join clause, which tells the database we need to match them up on year ID and team ID. So now we have a much more powerful table. It has data from both of these tables combined, and we can access all of this data from within our query. And so now when we said group by player ID, we don't actually want to group by the player ID. We want to group by, we don't want to group by the team ID. We want to group by the franchise ID. So we can remove the team ID from our query here. And you see it's updated the group by to be the franchise ID. It's going to show us the franchise ID here. So you see the power of a visual query builder, that we can work with a GUI here, drag and drop, check and uncheck boxes, and it builds this query for us. And we execute the SQL query. And now we see Hank Aaron is actually first. He has 733 home runs for the franchise ID ATL. That's the Braves, but it covers the entire Braves franchise history, including Montreal, Boston, etc. So you can see very quickly how we were able to query using multiple tables. And now let's just to keep the momentum moving. Let's say, well, these IDs are kind of ugly. We should really be using the players' names. And again, I can do this quickly because I know where to get the data, and that's in the people table. And so we can connect the player ID from the batting table to the people table. And we go back to our query. And we want to add the first name and the last name. And you can see it adds these just by checking them here. it adds them here. It added them to our select. And we can execute this query. And now we have first name and last name. So I hope this demonstrates how quickly and powerfully you can work with data across multiple tables. If we wanted to do something crazy like further subdivide this by players only in years that they won MVP votes, we can pull in the awards share players table. If we wanted to break this out by players who played, it's for certain schools or colleges, we can do that. All of the data is here in the database, and it can all be connected. So I hope that really shows the power of both, using the layman database and also tools that are built for databases and querying and so on. And so I'm going to go back to the slides. So, that's just scratching the surface of what's available. My slideshow seems to have disappeared. That's okay. We're running up on time anyway, so there wasn't really much left in the slideshow. I think the meat of what I wanted to show was actually playing around with the database, and giving everybody a chance to see in real time how quickly we can make various queries work. So with that, I am going to jump into the Q&A. So give me a second. There's a bunch of questions here, and I'm scanning them. Actually, the only question is, where can we download the layman database? And that link was already shared in the chat, which, and again, if you Google layman database, you'll find it. But yeah, it's always great to share the link. Yeah, can you show that again, how to calculate the sum of home runs for each player in the batting sheet? Yes, I can do that again because I was going quickly. I wanted to leave time for the Q&A. So, but if the Q&A wants to spend more time here. So I'm going to show it in two ways. First, how it's done in this visual query builder, and then how it shows up here. So the idea is that whenever you group data by something, so in this case, we're grouping by the player ID, the franchise ID, and then you have to, every other field that you include, you either have to group on it or you have to aggregate on it. And that's because we're taking multiple rows and we're squishing them into one. So you have to define how you aggregate them. So in this case, I'll just add another one. I will add doubles just to kind of show you how to do it again. So let's say we want career doubles as well. So we click that we want doubles. And when we first add it, by default, it has us grouping on it because every field has to either be grouped or aggregated. And we don't want to group on doubles. We want to aggregate. So I unclick there, and then I go to aggregate. And by default, so there are a number of functions that you can choose. Count means it'll count how many entries there are. That's not really what we want. You can choose average. You can choose max. Sum gives you the sum of the doubles. And I don't know why I put the quotation marks here. Those aren't necessary. So that's how we add doubles, and oops, we choose the aggregation sum. Well, now it did it twice. Okay. Oh, I know why it's the fact that it's starting with the numeric 2 kind of confuses the software. Let me use a different example that doesn't have this thing. Let's use RBI. So same thing. It's by default saying let's group it. I say we don't want to group it. So then it says you have to aggregate it, and we can aggregate by choosing sum. So that looks like the home run row now here. So that's how. So it's now part of the query, and it will. So choosing sum as the function, and by choosing sum here, it actually generates this code that says what we want is the sum of homers. So it's going to group by player ID and franchise ID. So going back to Hank Aaron's, we first added franchise ID here by it's not visible here, but it'll take all of these rows, all of these Hank Aaron rows that have the same player ID and the same franchise ID, and it aggregates them into one row, and it aggregates them by summing the home runs and RBIs. So if we execute this query, we already have the sum of home runs. Now we also have the sum of RBIs. So that's the cool. You could do this for all of the stats. This is how you get career stats. You can literally check every box here and choose to sum all of them. So it's really powerful what is possible. There was a question, why do I prefer dbeaver? I'll be honest, I don't have a strong preference. I chose it because it is literally because it's cross-platform. So you can download it on Mac and Windows. It has a visual query editor, and it has a trial version. So anybody here can download it for 2 weeks, decide if it's for you. There are free and student versions as well. I didn't look into the licensing as much of it, but at least with a 2-week trial, you can play with it and then decide. So for me, it was more, the cross-platform and the trial edition, and then it had the features that I use. I actually don't work with SQL directly that much. I prefer using Python. I'm a computer programmer by trade. I'm more comfortable working in Python. So these same databases, whether it's the comma-separated ones or the Access version ones, can be opened in Python and manipulated directly. So I often use Python. I write my queries in Python. I do my data viz in Python. Python has a ton of analytics libraries. You can do machine learning. I've been working on a projection system based on the Layman database, and it's all in Python. So I don't really use a tool like dbeaver that much. I just thought that it would be overwhelming to introduce both SQL and then another language in Python here. So I really wanted to stick to SQL. So with that, we're running out on time. There's still some good questions here. I'm going to be around at the conference the next few days, so would love it if anybody has more questions, wants to follow up. I'd love to talk about this. I've just kind of taken over ownership of this database, and I really am excited about people getting as much value out of it as I have over my career in baseball. So thank you for the opportunity, and I hope this has really piqued people's interest to try out playing with baseball data and playing with some of these tools. So thanks a lot. And with that, I'll turn it back to Scott.
Vinay, great job. Thanks for doing that. Thanks for leading us off today. And like Vinay said, if you are attending the conference in person tomorrow, then please stop by and say hello to Vinay and introduce yourself. I'm sure he'd love to meet you.